Following the announcement that BYD, or Build Your Dreams, had secured the order to supply Tesla with Blade Power batteries on October 22, 2021, some fresh developments have been in the BYD-Tesla collaboration. According to recent media sources, the Tesla Model 2, a result of the BYD-Tesla collaboration, is scheduled to be formally introduced in mid-2022 or the start of 2023. The Model 2 will be fitted with a new battery, a BYD Blade battery, with quite some advantages compared to the batteries Tesla has been using. Welcome to the Tesla News Hangout. Today, we will discuss Tesla's new Blade battery and why it will destroy all its rivals. What makes this battery so unique? And how will it change the future models of Tesla? In August 2021, Musk stated in Tesla's second quarterly report that the company would progressively transition to a lithium iron phosphate battery architecture in the future. Lithium iron phosphate batteries will be used in 2/3 of Tesla batteries in the future. BYD also stated in early 2022 that it would provide Tesla with lithium iron phosphate Blade batteries starting in the second quarter of 2022. The Tesla model equipped with Blade batteries had entered the last testing phase. BYD is one of the world's largest lithium iron phosphate battery producers. The Blade battery is made of lithium iron phosphate, which improves battery mileage and enhances battery safety. BYD has developed a lithium iron phosphate battery facility in Lancaster, Pennsylvania, to supply batteries for BYD electric buses marketed in the United States, which further supports the assumption that Tesla is set to employ BYD Blade battery. Although the factory only has a capacity of roughly 1 gigawatt-hour, it is just about 500 miles from the Tesla Fremont plant, and it can fulfill Tesla's early demand for lithium iron phosphate batteries by modernizing the production line. Whether the facility is in Fremont, California, or Austin, Texas, it should follow the idea of local matching for cost reasons. It is unlikely to ship cells or battery packs by sea. BYD has an obvious advantage because it owns a power battery facility in the United States. It's possible that Tesla may switch to Blade batteries even earlier than expected without using BYD batteries, but we will get to that. The collaboration between Tesla and BYD is a win-win situation. BYD battery supply will reach new heights, while Tesla's competitiveness will improve. The lithium iron phosphate batteries are safer and cheaper than ternary batteries, which is more favorable to Tesla's development. The Blade battery was also created to make the most of the space available within the battery pack. According to BYD, the Blade battery uses less space than a traditional EV battery. Each blade is 96 centimeters in length, 9 centimeters in height, and 1.35 centimeters in width. The individual cells are stacked in an array before being put into a battery pack. The cell-to-pack architecture removes the need for multiple battery modules inside the pack, each with its heat management system and electronics. Compared to typical cylindrical lithium iron phosphate batteries, the usage of available space is improved by approximately 50%, giving the batteries a better energy density since more cells can fit. The Blade battery also solves the issue of safety. The combustion and explosion of lithium-ion batteries are one of the most severe issues impeding the growth of the EV market. Overheating batteries have caused fires in Tesla, Hyundai, General Motors, and NIO Inc. electric vehicles. However, as EV adoption rises, the risk of battery fire rises unless EV batteries can be made safer. Hyundai recently recalled 82,000 electric vehicles to fix battery packs that might cause a fire. This is one of the manufacturer's first large-scale recalls of electric car battery packs. According to Hyundai, the cost of recalling the battery packs is estimated to be over $900 million. The cathode ingredient of the Blade battery is lithium iron phosphate, LFP. According to BYD, it provides a greater degree of safety than standard lithium-ion batteries and superior strength, range, extended life, and power. Even at temperatures as high as 500 degrees Celsius, LFP is more stable battery chemistry. The BYD Blade battery has passed the industry's so-called Everest test of being punctured by a nail to verify it won't burn to demonstrate its durability. The nail penetration test replicates a battery's internal short circuit, which is the leading cause of battery fires and combustion. The Blade battery was also able to withstand an extraordinary strength test, in which it was rolled over by a 46-ton heavy vehicle. The national standard is less demanding than the heavy truck test. The battery passed the test without leaking, deforming, or emitting smoke. The Blade battery pack, according to BYD, was in pristine condition and ready to be utilized in an electric vehicle. BYD also claimed that their Blade battery has undergone additional rigorous tests, including being overcharged by 260%, crushed, bent, and cooked to 300 degrees Celsius in a furnace. There was no fire or explosion in any of the testing. According to BYD, the Blade battery is the world's first EV battery that can safely pass these tests. BYD has 26 years of battery research and development experience. Blade batteries' design and manufacturing process were created wholly in-house. BYD has said that it is currently increasing its Blade battery production capacity. Some of the car industry's major players, according to the business, are beginning to rely on this ultra-safe battery technology. The Blade battery is intended to be fitted in EV models from major companies, including Tesla, as top global automakers cooperate with BYD battery. Tesla's CEO Elon Musk announced in 2020 that the company's entry-level model would be available in 3 years. It has yet to be given a name, although it is commonly referred to as the Tesla Model 2, and others have suggested that it will be called the Model C. There is no official communication yet concerning the last name. According to reports, Tesla's next car will be positioned beneath the Model 3, and will disrupt the auto market with the lowest price in the EV industry due to the use of the BYD battery. In a February 2021 interview, Zhu Xiaotong, president of Tesla China, stated that Tesla intended to finish the whole process of design, development, and manufacture of a model in China, and that the project had begun an environmental review. According to the environmental assessment study, the Shanghai Tesla Super Factory will also enhance the manufacturing capacity of the Model 3, Model Y, and associated derivative products by using the new Blade battery. At this moment, Tesla's new car's research and development is extremely private, and the model's name, launch date, and particular pricing are all speculative. According to Tesla's official literature, both the Model 3 and Model Y with lithium batteries have standard battery life versions, with the Model 3 having a battery capacity of 55 degrees kWh, and the Model Y having a battery capacity of 60 degrees. According to this estimate, the 45 GWh battery procurement from BYD will be enough to power approximately 800,000 automobiles. Media sources also say that Tesla intends to place more orders in addition to the 45 GWh batteries it has ordered from BYD. Battery suppliers compete with each other on a multi-party basis, and one of Tesla's possibilities is Guoxuan High-Tech. Guoxuan High-Tech announced that it had recently signed a strategic supply and localization agreement for a large publicly traded automobile company in the United States. The two parties hope to reach strategic cooperation in supplying and procuring lithium iron phosphate batteries. The two parties are already in talks. According to the deal, the auto firm is slated to buy at least 200 GWh batteries from Guoxuan between 2023 and 2028. Tesla is one of the few automobile companies capable of purchasing lithium iron phosphate batteries with that capacity. However, because Tesla's new car will be manufactured in Shanghai's superplant, Guoxuan High Lithium Techie's iron phosphate battery is unlikely to be used in Tesla's new automobile but older versions. Tesla could not allow the BYD battery supplier to remain dominant for supply chain security, so it's only reasonable that it hunted for a second and third source of lithium iron phosphate. Suppose Tesla's new vehicle sells for only $25,000. In that case, it will pose a significant danger to both new car-building forces and conventional car firms, and many brands, such as Nezha, Weimer, and others that focus on less than 100,000, will be forced to compete with Tesla. For power battery companies, much of the capacity of power batteries increased after entering the Tesla battery supply chain agreement and are projected to gain additional innovation over time. Tesla is a catfish that has shifted the winds and clouds of the new energy automotive and power battery industries and may do it again using this Blade battery. Despite the high competition in the EV sector, Tesla may monopolize the space with its new battery. Do you agree? Please leave your thoughts in the comment section below. Do not forget to subscribe to our channel Tesla News Hangout, where we talk about Tesla and electric vehicles. While you're at it, hit the bell so you never miss any of our videos, as more exciting ones like this are on the way. I'll see you in the next one.